Bishop grades and reporting. All right, so bell ringer first. Over here. Remember, all your missing work is Friday. If I get it to you on paper, you will hear them again in paper. I've got to have it Thursday, or somebody's got to drop it off here Friday morning, so I can get it in. All right, so 2-9 is our bell ringer. All right, who was the first to name the atom from yesterday's notes? In other words, who gave the name? Oh, I need to be here. Name starts with a D.
Dalton.
Not Dalton, there's another one.
Demo.
Democritus.
Oh, no, that's a name? I guess so.
Democritus, I think that's right.
I'm sorry, but I had to look it up because I did not know.
I think that's close enough.
Wait,
He was the Greek philosopher from about 400 BC.
replace that A with an I. And then you put a U behind the T.
Mm-hmm. Oops. There we go. All right, who believed electrons were in a fixed orbit, kind of like our solar system, planets in our solar system? Name starts with a B. Funny spell. His last name starts with a B.
I don't know.
First page of the notes.
Niels
Niels Bohr.
Huh?
Oh, yes, Niels Bohr. What is the where is the mass of the atom located?
In the nucleus.
Very good. And where is the volume of it located?
In the nucleus.
Volume is the space it takes up. What do we call that?
Around it?
Yeah, we call it an electron cloud. Or around the nucleus. Well, I typed this morning. And then which subatomic particle has a positive charge? Which particle of the atom has a positive charge?
Say it again.
Which subatomic particle of the atom has a positive charge? 3 parts to the atom.
Proton.
Proton. All right, guys got that?
Yeah.
With that. Now, yesterday, if you were here, I gave you a periodic table. You can put that out. I'll get you one, Delaney. You'll want to have that handy for the notes we're going to talk about today, because you're going to want to be able to use that periodic table. I put a file here that you can download so you can access it and have it. It's here, but here's a paper copy. We're going to be doing the isotope notes today. And I have a copy for you if you want to do it on paper. Remember, it's helpful if you do it on paper to also just submit the blank. That way, it helps me remember I have to then look at your paper as I go through grades. We'll be handing progress reports out tomorrow. So if you've got missing work, it won't have all the missing work, graded, because you still have till Friday to get it in. But we will get progress reports tomorrow because it's halfway through the first quarter. So we're going to look at the notes. If you're doing it on paper, you don't really have to go here, other than you want to make sure you submit the blank notes there. If you want to do it on the computer, just look at the PowerPoint up here and scroll. This is just vocabulary. So again, here is the periodic table. And we're going to be looking at all some of these numbers here. So what you may want to do on your periodic table is do some labeling in just a minute. So atomic number is going to be the top number. So on your periodic table, you may want to, underneath the title, where it says periodic table of elements, you may want to draw this box of hydrogen right here. And you may want to label as we go.
You know, hydrogen is like rearranging.
Yeah, but this is just so you know what it, yeah. This is just so you know, it's some kind
But
of.
you want us to circle the one, say atomic number?
I was gonna say, if you wanted to draw that box right here kind of as a key,
The whole thing?
yeah, just that box, and then you can label it. And you can say that this is the atomic number, so you can always refer back to it. Does that make sense? And it's not messing up the part you've got to see. This tells you the number of protons. Okay, so the top number on the periodic table. Now, if you look up here, this one is still on the top, but it's in the right corner. Yes?
Would you send her to the office computer me, please?
Okay.
So leave. Where's the devil? Look.
Ma'am,
She doesn't understand why she's leaving.
her mom is on her way to pick her up.
Okay. Do you want to take that paper sheet with you to work on at home and bring back?
Thanks.
Yeah. Quicker you get them back, quicker I can put it ready in.
Okay.
All right, so. This is your identity. Think of the atomic number as like your social security number. It's the identity of the element. If that number changes, you get a different element. And the periodic table is arranged by those numbers. So if you look up here, it'll start with 1, it goes to 2, 3, 4, 5, 6, so they're in order by atomic number. And we're going to learn more about what makes an atom not neutral, but for what we're doing right now, protons will always equal electrons. Very, very important. So this number will tell you number of protons and electrons for right now. And then you have the symbol, which is self-explanatory in the middle.
Almost. I just have to do the little dashes. Number.
I had put separate blanks for each word if you were handwriting it, so for what you can just put one text box for that last part, where it's got the different multiple blanks.
Alright.
So then the only other number, it always has the name, and then this bottom number here is the mass number. So the decimal number.
Wait, what was symbol? Sorry.
Hold on.
Okay, I got it.
Good. All right, so mass number, if you want to label it on your periodic table, is that decimal number at the bottom. And so, it says not on the periodic table, but if you round that decimal number, that's the mass number. It's the number of protons plus the neutrons. You have to round it, on here. Sometimes, and this is going to give you, on the periodic table, it's going to give you the average atomic mass. So if you round, it's going to be the most common isotope. So we're going to get into that in just a minute. So if I wanted to find the mass number of these atoms here, carbon, all I'm going to do is I'm going to add up the P and the N. So 6 plus 6 is 12, 9 plus 10 is 19, and 20 plus 20 is 40. So that is how you do mass number. Now, if I knew protons and I didn't know neutrons, I would then take them, and I knew the mass number, I would subtract to get the neutrons.
Wait, so how do you know to multiply?
If you're adding.
Oh, you're adding.
Yes.
But right there, oh, okay, sorry. Okay.
So, but
How do you know to add it then?
oops, hold on. Because the mass number is always protons plus neutrons, because they're the two that have mass, and they're in the nucleus. Sometimes you're only given protons, and if that's the case, and you don't know the N, and you know the mass number, you can take the mass number, subtract the protons, and it gives you the neutrons. So we're going to practice a little bit. I don't know if this chart I'm getting ready to do, yeah, it's on there. Good. So we're going to practice a little bit here. So, and I can't write on here the way this is set up. It'll be. Okay. So on here,
Wait, can't you just put them little, that's a.
yeah, I can write with this, and it's not going to show up on my video. That's the problem with this. If I'd have thought ahead, I would have taken a screenshot and put it on my Jamboard, which I might be able to do real quick. So let me wait a minute here. See if I can. Let's see here. Did I do it? No. Can't do it on here. All right, so I'm going to tell you what to put here. So if you look here, this is your element. So if you take your periodic table, one that I can look at. Al is in the middle section. It is aluminum. Well, not the middle section, it's number 13. So find number 13, right here's aluminum, Al. And notice it says atomic number. Atomic number is that number at the top. And I said it was number 13, so you're going to put 13 under atomic number.
There's two numbers. Oh, wait, it says mass number now.
Yeah.
And that's gonna be the, that's gonna be 26.98.
No, hold on.
Oh, okay.
I need to. Let me escape out of here in a minute. Oh, there is my screenshot. Ah, okay. Now I'll be able to write. Oh, I'm gonna. Oh. Okay. So let me get this bigger. Now I can see. All right, so now I can write. So I'm going to just sit here and do this. So I'm going to click here on the periodic table. the number at the top for AL was 13, so you're gonna type, maybe, $13 there. That must be so finicky. Okay. All right, now I'm gonna skip mass number. I'm gonna use this right here, and I'm gonna, this column, and this column will all be the same number for what we're doing right now, okay? Because atomic number tells us number of protons. So I'm gonna go over here and I'm gonna add 13. And it also tells me number of electrons because we're going to assume all of these are neutral atoms. So they're going to have the same number of electrons as protons. Now, mass number, remember, is protons plus neutrons. So I'm going to add these two together. So I'm going to just put me a little help up here. I'm going to put my little text box, and I'm going to go up here, and I'm going to write P plus N, just so, N. So I know that up here, I'm going to add those two to get that, okay? So 13 plus 14 is 27. So I'm going to do 27. And that is how we fill in this chart, okay? So here, I'm not given the symbol, but I'm given number of protons. Number of protons, I know, is also the atomic number. So I'm going to go ahead and put 25 here. Where else am I going to put 25? What other column has a star?
Number of electrons.
Number of electrons. So I'm going to duplicate that so I can drag it over. All right. Now, I'm going to look on my periodic table and I'm going to find number 25. So I'm going to look at just the top numbers. And what is the symbol for 25?
MN.
All right. Capital M is very important. Capital M, lowercase n. You have to follow that way of writing the symbols or it's going to get very confusing later on. The first letter is always capitalized. If there's a second, it will be lowercase. Now I need mass number. And to find mass number, what am I going to do? Add protons and neutrons. So this time, what is that going to be? 25 and 30
50.
is 55.
Oh. Wait,
25.
you're adding them all together?
No, just these two.
Oh, I thought we were doing 25 plus 25.
These two.
Oh,
Protons and neutrons, P and N. So that's going to be 55.
plus. I
Now,
need to put that P plus N thing above that mass number.
if it'll help you.
Yeah.
It's not always going to be P plus N. Sometimes it might be the mass number minus protons.
And how would you know that though?
I'm getting ready to show you in the next two. All right, so let's look at this one. I'm given atomic number. So I know atomic number can also go in protons, because I put that star there, so I'm going to put a 47. All right, and then I know that I'm going to duplicate that. And it also goes here in electrons. Now I'm going to use this atomic number 47 on my periodic table. I'm going to find 47. And what is the symbol for 47?
AG.
AG.
Capital A.
And I believe that is silver.
Yes.
Gold is AU, sometimes I mix those up. All right, so there's there. But now I'm given my mass number. Now, if I know that my mass number is protons plus neutrons, I don't know my neutrons, but I know my protons, so the opposite of add is subtract. So I'm going to subtract these, and so you can use a calculator if you cannot subtract this. So over here, to get, if this will,
Wait, 47 minus 109,
yeah, 109 minus 47.
62.
So this is gonna be 62. So when you're given the mass number, you're either gonna subtract protons or neutrons. Usually it's gonna be protons that you're subtracting. Because you can find protons very easily. So if you need number of neutrons, so I'm gonna add something up here to help. If you need number of neutrons, you're gonna take mass number minus protons. Oops. To find neutrons. Now, I didn't fix this before I put it up there. That should be an 11 here. All right, so I know number of protons is 5, so I know where I can put that. I can put that in atomic number. And then I can also put it at electrons. All right,
Boron.
boron, very good. Is it just a B?
Yes.
So you use the 5, look on your periodic table, and it is a B, just a capital B. Very, very important to follow. If it's just one letter, it's capital. If it's 2 letter, first capital, second lowercase. Now I'm going to do the same thing as I did before. I'm going to take the mass number minus the proton. So this is 11 minus 5 is,
Are you asking me?
yep,
6, I think.
yep.
Yeah.
I'm good, Ron.
I'm not good at math at all.
That's why I'll give you a calculator.
So the reason we were doing mass number minus P, was it because that was an empty space? Because last time,
Up here, we had an empty space in mass number.
and that's why we did P plus
That's
N.
when we did P plus N. When we have an empty space for neutrons, we have to do mass number minus P.
Will there ever be an empty mass number and number of neutrons?
Shouldn't in what we're doing, because then you can figure it out.
Okay.
All right. So that's, let me get back over here. And get this back up. Now, we're gonna do something similar to this, in some practice in just a little bit, but we're gonna add one more piece to it. So here was some, help here. So just like I said, on periodic table is what they said here, you find that. This is your protons plus your neutrons. This is the same as the atomic number, mass minus protons, and then this is the same as the protons, so kind of like what I did there. So this will go through and we can check and see if we did it right. All right, now, what we're going to be looking at is isotopes. All right? So, not all elements that are shown on the periodic table are the same. And the one way that they can be different is with the number of neutrons. So each element of hydrogen can be a little bit different based on the number of neutrons it has. So that number can change. So the atomic number will stay the same, that's the number of protons. But the mass number is going to be different because the number of neutrons is different. So up here we have hydrogen 1, and this is called hydrogen 1 because it has a mass of 1, it has 1 proton. Hydrogen 2 has a mass of 2 because it has 1 proton and 1 neutron. They're isotopes. The only difference is the number of neutrons, which makes the mass number different. So an atom is most stable, or an element is most stable when you have the same number of protons and neutrons. So it has enough energy to keep that nucleus together. But if the neutrons and protons are different, it becomes unstable, and that's where you get your radioactive elements and things that can decay that we'll get to later. All right, good.
I got it.
All right. So there's a certain way that we write isotopes. There are 2 methods for doing this. You can have the hyphen form, which we just saw. You have the name of the element and hyphen or dash the mass number. So potassium dash 40. We had on the other slide hydrogen dash 1, hydrogen dash 2. This would be an atom of potassium with a mass number of 40. This tells you the mass number of protons plus neutrons. There are 19 protons because potassium has this atomic number, and it will always be 19 for potassium. If it were to change, it would be a different element. But the neutrons in this case are 21 because you take the 40, subtract the 19, we have 21 neutrons. We can write it what we call the nuclear form. This is the symbol with the mass number at the top left. So as a superscript on the left side of the symbol. So we could write potassium 40 as capital K with a 40 in the upper left-hand corner. The nuclear notation can also, sometimes you'll see the atomic number down here. So you would see 19 under it, but a lot of times they just do the 40 because you can always get the atomic number from the periodic table. All right, so here we have some examples for notation. So write the hyphen form and the nuclear form. If I were going to write the hyphen form, B, if I look on my table, is boron. And I would find it by looking at the P, which is 5. So I would write boron hyphen, and then I would go 5 plus 6 is 11. So boron hyphen 11. If I were going to do the nuclear form, I would put the symbol with the 11 up here. Now to type on there, there's a little, when you get your text box, there's a little menu bar that appears. I think there's a T with a little 2, and you would just use that first.
But now you can do shift and just hold the 6 down.
Oh, you can?
They do that
Okay.
now, yeah. They fixed it where it's like that.
I don't know all the shortcuts, so
That's okay.
I switch between Mac and PC and Chrome, and so I never can. So here, Na is sodium. If I didn't know that was sodium, I would look at the protons. I would find number 11, and I would see that it was sodium. So I'd write sodium hyphen. I would add the 11 and the 12 together and get 23. And if I was going to then do the nuclear form, I would do Na with the 23 in the upper left-hand corner. And we're going to be doing some of this in a chart today. So isotopes, the only thing that is different is the number of neutrons.
Wait,
Now, the average atomic mass is what is the official name for this number down here. And that is because they take all the isotopes' weights and average them. And that's why there's a decimal. And when you round it, you get the most common isotope for that element. So a lot of times I will interchange mass number and atomic average mass for this number down here, but it's really the average atomic mass because it's an average of all the weights of all the isotopes of that element. And when you round this, it's going to be the closest to the most common isotope of that element. So for hydrogen, hydrogen 1 is the most common isotope. And a lot of times we'll call hydrogen just a proton because hydrogen 1 just has a proton. We've got one more chart that we're going to practice with, and I'm going to see if it'll pop up here. It does not, don't worry about that. All right, so I want to go down here. I want to get this chart right here, so I'm going to print screen again. See what happens. Yay. All right, I'm going to come over here. I'm going to paste it. Give me a minute to get this up. And we're going to do this chart together because it's going to be similar to what you're going to do for practice in just a minute. So let me drag. I can crop it on here. Going back and you're not doing it here. I can't really crop, but I can keep making it bigger. So I can get where I want to see. All right, so now we can see that pretty good. So what you're going to do here is you're going to look, and what you may want to do first is I like to kind of put a dot or a star over the ones that are going to be the same. Remember, we get that from the periodic table. Then you may want to add up above mass number to help you that this is P plus N. Oops. And you might want to add above number of neutrons that it is mass minus N. It's mass number minus N, but I'm not going to have a lot of room to write that. So I'll put that there to kind of help. So we're going to start with carbon. Well, when it's written like this for the isotope name, I automatically have my mass numbers. So I can come over here and I'm going to put the mass number for this one be 12 because the 12 is in its name. Then I'm going to find carbon on the periodic table. And I happen to know that carbon is number 6, but you have to look for the symbol until you find it. So I would come over here, and I'm going to put 6 here, because it is number 6 on the periodic table. I know that that 6 is going to go for protons and electrons for what we're doing here. I know that to find the mass number, or the number of neutrons, sorry, I've got to take mass minus 6. Well, 12 minus 6 is 6. So I'm just going to duplicate this. So having this up across the top is kind of helpful. Now notice here, this is still carbon because you have the C, but look at this, it's 13 now. So its mass is different. So that means my number of neutrons is going to be different. Oops. So we get the 13 in there. The atomic number stays the same. So that means then the number of protons stays the same. The number of electrons stay the same. But my neutrons is different. 13 minus 6 is Since it's one more than 7, one more than 12, I know it's gonna be 7, I'm gonna give it to you there. So I'm gonna put a 7 here. So notice the only thing, oops, goodness. The only thing that's different is mass number and neutrons. Are you understanding how I'm getting each of these numbers? All right, hydrogen 1, I know that its mass is 1. If I look at hydrogen on the periodic table, its protons is also 1. So I'm gonna duplicate these 1s for a little bit here. That means I'm gonna put a 1 for protons.
Also, it's the same way for the, wait. The other table looks kind of the same.
Yeah, it just didn't have the isotope thing.
Okay.
All right, so here I have to remember subtract mass and protons. I get 0 in this case because hydrogen 1 does not have any neutrons. 1 minus 1 is 0. But here, notice I have a 2. So that means that my mass number is now 2. But my atomic number doesn't change, it is still 1. My protons doesn't change, it is still 1. My neutrons doesn't change, not neutrons, my electrons doesn't change. My neutrons have changed, so 2 minus 1 is 1. All right, now we have lithium. Lithium is actually in the first column on the periodic table.
But it doesn't have a 6 right there. On the
Oh,
table.
right. It doesn't have a 6. This is the mass number. So I'm going to go over here for my mass number, and I'm going to put 6.
Oh, okay.
And then from the periodic table, I'm going to use the top number, which is 3. So I'm going to put a 3 here. And then I'm going to put that 3 in the other 3 columns I have. So it's the atomic number, it is the number of protons, it is the number of electrons. Then I'm going to go back and I'm going to subtract mass and protons. This case, my neutrons are also 3 because 6 minus 3 is, 6 minus 3 is 3. Now, if I look down here, I have a 7. So in my mass, this time I'm going to put a 7. My atomic number doesn't change. My protons doesn't change. My electrons doesn't change. Oops. Oh, let me forget. Oh. Okay, down there. And then, but my neutrons, 7 minus 3 is 4. They've changed. So if you've done this, you're going to submit on your computer. And then there are actually 2 videos that go over this that will help. One just has 2 little questions, and the other is a little more detailed. So you can watch those first, or you can do those at home. Just don't forget to do those. And then I'm going to give you your practice sheet, and you may have to finish this up at home. So I don't know if you'd rather do this on paper or online. I don't care, but I'm going to let you see a paper copy. You've got 2 tables. You've got a table on the front and a table on the back. And you may come across some that we've already done, so find where we've done it and just copy that information over. You've got some questions under part 1 Let me open this up. And so, questions under part 1 are having to do with the 3 carbon isotopes that are at the bottom. At the top. I don't know if you guys are getting that out or not, if it's just me, but
Yeah, that keeps
just
happening.
click out of it.
Sometimes it don't even pop up, you have to read the
Yeah,
whole
I
thing.
don't. So you're gonna use these 3 isotopes. You've got carbon 12, carbon 13, carbon 14. You're going to answer each of these questions based on this information, and you might need to refer back to your notes. So 1 through 9. Then you're gonna complete this chart, just like we did the one in the practice. So if you want to up above here, put a dot above atomic number, number of protons, number of electrons, so you remember. Mass number should be, or may not be given, so it's gonna be P plus N. And neutrons is mass minus P. So you can add that, and you're going to complete that chart. And then you're gonna have one more practice with the chart here. And look, this one is repeated again, so you can just get it from the other chart. And then you have 3 questions afterwards. So this is what you're going to work on for the practice.
Oh my gosh, that's a lot. I'm just kidding. I don't know how to do the charts really, they're easy, it's just like,
Yeah, it's just like what we did. That's why if you, did I lay a paper, cut? You may want to write it on paper. Sometimes doing the charts is better on paper, just because you don't have to worry about flipping it in that text box and everything.
okay, but then you're gonna think I didn't do it.
Well, then you just submit a blank one if you're doing it on this,
Okay.
and if you don't get finished, you just have to bring it back.
Okay. Do I have time to do this?
You should have time to get most of it done.
I don't even know what time we leave, I always forget.
I think it's 25 after.
Okay. Okay, so only this and that?
Yeah.
Oh, wow. Okay. Well, alright.
So it's up to you. If you'd rather do it on the computer, you can, or if you want to do it on the paper first and then type it in on the computer, you can do that.
Okay, I can do that.
Whichever way well, that's why I'm giving, when you're here, you get the option,
Alright.
because it can. Stop this. I don't need all that downtime recording. Oh, I didn't get yesterday's fees.